Welcome to this video and thank you for watching simple regression using Excel. The first thing we have to do is to activate the data analysis package. So after opening up the file options menu, we click add-ins, we go to Excel add-ins and we check the analysis toolpack. Let's take a look at our example. The dependent variable of our analysis is the sales of a company, and the independent variable is its advertising expenditures. And we want to build a simple regression model that connects these two variables. So after opening up the data analysis package, we select regression. Here we include our dependent variable, that is sales, and here we include our independent variable. As we have included both the values and the labels of the variables, we do not forget to check the labels checkbox. And we keep the confidence level in its default option, that is 95%. And here we can select what we want, what plots and what tables we want. Here is the most important part of the output. The value of the intercept is equal to 757 and the value of the slope is close to 3. However, we do not care only for their values, but we care for their statistical significance as well. We can see that the p-value of both variables is significantly lower than 5%. So both the intercept and the slope are statistically significant. The first measure discussed is multiple R, or the multiple correlation coefficient, that measures how strong is the relation between the dependent and the independent variable. A value of 0 indicates that the explanatory variable provides no insight into predicting the dependent variable, while a value of 1 implies that the explanatory variable can give an accurate prediction of the dependent variable. The square of the coefficient of correlation is the R-square value. Here in our examples, it indicates that 90% of the variability of sales is explained by the advertising expenditure, that is our explanatory variable. On the third line, we have the adjusted R-square. It has been developed by statisticians to take into consideration the impact on the regression model that any new independent variable brings. So we are going to cover this topic when we discuss about multiple regression models. We are not going to cover ANOVA, as it is going to be discussed in another video, but we are going to discuss the residual output. Here is the number of our observations, and here is the value of the dependent variable as predicted by our model. The difference between the actual and the predicted value of the dependent variable is called the residual, and as you can see, the sum of the residuals is 0. And here, as you can see, the residuals can be expressed as standard residuals. So if you calculate the standard deviation of the residuals, and you divide their value with the standard deviation, you can calculate the standard residuals. Last but not least, here we have our residual plot that displays how residuals are scattered around the x-axis. The plot helps us evaluate how trustworthy is our model at presenting our data. Our residuals should not have a clear pattern and should lie around an average of 0.